This is a conversation with Carl Zimmer. Carl's a science writer for the New York Times and the author of famous books like Life's Edge and She Has Her Mother's Laugh. We discuss the shifting line between life and non-life, what biology and evolution can and can't tell us about aging, the ethics of brain organoids and embryo screening, and how good storytelling shapes public trust in science. This is the Acc Podcast. Please enjoy. I have read a couple of your books. One of my favorite of your books is actually Life's Edge. You have this great line where you say that we feel in our bones that making sense of life should be easy, but these clusters of neurons prove that it's not. I really love that line because I think it captures this human frustration. We want life to make sense, something that we can define, that we can solve. But what you show in the book is that life keeps slipping away when we try to pin it down. You go through all these different examples, viruses, synthetic cells, brain organoids, all of which I loved, and none of them fit quite neatly into that definition of life. They're alive, but not fully. So I guess instead of asking you the classic, what is life question, I wanted to flip it around a little bit. Do you think that there's something that life is trying to avoid? Because from the outside, when you look at living things and living systems, they seem obsessed with holding something off and they're always resisting decay and stillness. So I was wondering if you've ever thought about that question about how life might not be a state of being or a thing, but just this kind of resistance, maybe like a refusal to stop moving. And I understand this is a very detailed question to start off with. So if you need some time to collect your thoughts, feel free, take your time.
I think that avoiding things you're describing, I would fit that under what biologists call homeostasis. In other words, the way an organism is trying to maintain some sort of inner balance, inner equilibrium. It will be getting away from the things that could disturb that. Obviously, a predator will just tear it apart and eat it. Organisms will also move away from heat or cold if that's bad for its internal state. So, I guess I wouldn't say a hallmark of life is getting away from stuff, but I think it would be
Sure.
more. I think I would just fit that under the broader hallmark of homeostasis, just trying to preserve that balance, which is very different than the state outside of it.
Yeah, the reason I was thinking about that is because it was intriguing to me that maybe biology isn't just the state of being, but this kind of resistance that aligns a lot with the human experience, like that constant push to survive, to adapt, to endure. And I mean, we've seen that like aging as a process, it's not something that we've evolved to do necessarily, but it's just something that happens because of things that we're born with. And so it's only natural that we're going to age. And so I've just been thinking about that a lot and thinking about why we exist on this planet, why we were destined to die, and whether there's a way that we can reconcile why we age at different paces of different organisms and just those types of thoughts. And I think that you
Well,
talk about that.
yeah, I was
Go
going to
for it.
say aging is really fascinating to me. I've done a lot of writing, reporting on it, on the science that is being done on it. It's not just a philosophical question, it's a specific scientific question, and it's being addressed in a lot of interesting ways. And different kinds of scientists are looking at it from different perspectives. So,
Yeah.
a molecular biologist might say, okay, I'm going to go into cells and catalog all the changes that seem to be happening as organisms get old so I can find some sort of molecular aging. There's a lot of work done with that. That's the basis of these biological clocks that you can actually go and pay for
Right.
yourself if you want to see how biologically old you are. The evolutionary biologists will say, well, okay, why do we age? But asking that why, not in a religious sense or a metaphysical sense, but just how has evolution unfolded so that we age, most things age in one way or another. It comes down to the basic fact that living things are trying to keep a bunch of molecules working together in this incredible symphony.
Yeah.
And you need energy for that. The way that we make fuel and burn fuel produces a lot of cellular damage. Cellular damage is a fundamental part of aging. So we
Yeah.
need energy to live, but as we burn that energy, we are damaging the things that keep us alive. Our ancestors evolved, other animals have evolved, and other organisms to basically balance this trade-off, so that there are a lot of mechanisms to repair damage, but they take a lot of resources too. So basically, in a simplistic way, the evolutionary solution, quote unquote, is to do a really good job of repairing the damage in the early years when organisms can reproduce, and then just let things slide and fall apart later. That's basically aging.
Yeah, I think that's a really good analogy there, that living is kind of like a trade-off situation of how much energy is the body willing to expend on keeping us alive basically, and repairing all the DNA damage that's happening every single day. And I guess at one point our body just tires out and is like, this isn't really worth it anymore. Or maybe we reach a certain threshold to where the damage is just unrepairable. And so I know you obviously don't work in the aging space, but these are just some questions I've been thinking about recently. I've been talking to some people who are really interested in aging and longevity research. And a lot of them are trying to contend with the fact that what is the most optimal solution to try and stop aging? Is it things that we should supplement our body with? That is it senescence? Like, should we be trying to reverse the biological clock, basically? I feel like the questions you tackle through your books, maybe you don't intend for it, but it gets at some of those questions on what it is to live and die. Then maybe we can try and develop the best solution to try and prevent dying from happening, if that makes any sense at all.
These are big questions that a lot of scientists are also quite consumed with. I don't think we really have great insights into what could practically work as a way to live a dramatically longer life. You can certainly buy lots of things where
Yeah.
people suggest that they will, but none of these have been vetted by the FDA. None of them have clear evidence from clinical trials. These are interesting questions. I would just caution people not to think that means that immortality is one trip to the drugstore away.
Yeah. And I don't think that's the type of narrative or messaging that the field is really trying to get across, that we should be living forever. It's more about, can we, prevent some of these diseases that are related to aging, or can we try and, to our best possible degree, increase health span and improve quality of life, I think is the main idea there. And so,
Yeah,
yeah, I can definitely see how that can be misinterpreted by people who maybe aren't as familiar with the precise research.
right.
Definitely a cautionary tale. I wanted to talk to you about one of the moments in the book that really stuck out to me and honestly freaked me out a little, when you started talking about brain organoids,
Mhm.
these little clusters of neurons that are grown in dishes and at some point started producing electrical activity like brain waves. And I found that really astonishing, but honestly a little bit uncomfortable as well. It made me think about, what if biology is on this path of accidentally generating something that it doesn't recognize as conscious until it's too late? In your view, would that be a breakthrough in science, an ethical challenge, or what is your view on that?
It's a question that scientists and bioethicists are deliberating. There have been breakthroughs that have been ethically dubious in the past, and this might be one of those, because if you bring something into being that has consciousness, you have an ethical duty to it. And so just to do that and without a plan for what you're going to do once you've made it is not responsible. This is my view, having talked to a lot of bioethicists about these
Mhm.
issues. That being said, it's a little bit like immortality. Like, I don't actually think that anybody's going to be making conscious brain organoids anytime soon, m- mainly because, consciousness, like life, is something that we all intuitively know that we have, but is doesn't really have a firm theory to explain it. That doesn't mean there aren't theories of consciousness. I was just reading one survey that counted 29 theories. Like, these are theories that people are actively researching right now.
Sure.
And so we don't really have a handle on consciousness. And so I don't know how someone is going to figure out that, some little clump of cells in a dish
Yeah.
is conscious. That being said, if it start, you could imagine that it could start to learn. There are very practical, straightforward ways to measure learning, even if you're just looking at a bunch of neurons. You don't have to talk to it. You just put in probes and record the electrical activity. So you could give it a pattern of,
Oh, wow.
electric signals and then just wait to see what it does. And you can observe learning that way. That's not quite consciousness, but it could be something significant.
Yeah, that was a very theoretical question, but I just really wanted to get your views on that. That's a big part of the book that stuck out to me. Speaking on this conversation on consciousness and how we can't really define it right now. There's many theories. I wanted to actually talk to you about software. We have these language models that can pass Turing tests and algorithms that are very complex and are growing more and more sophisticated. There's this theoretical idea floating around, especially in conversations on AGI, that one day, with enough compute, AI can start doing machine learning research and not just running models, but designing new ones. And so that's kind of a scary future. But for me, it raises this question, if we can eventually build systems that evolve themselves in this kind of artificial loop, what do you think that means when the behaviors we once thought were unique to life, these behaviors of learning, of self improvement, and maybe even like emergence start showing up in software? Have you thought about this? I'm not sure if you think about consciousness very often, but I was just curious about what you think about the behaviors that we typically associate with humans and intelligent behavior. If we start seeing them in AI, how we should go about dealing with that, or if you think that's even going to be possible.
I think we're going to have to be careful with the language we use to describe these pieces of software. If you've got a company and you want its stock price to go up, it's in your interest to use very dramatic language to
Sure.
say, we are on the verge of creating artificial general intelligence and we need to prepare for this new coming age and so on. And, by the way, buy our stock because we're making it. And
Sure.
I feel that when you hear these people who own these companies making promises, you have to bear in mind that they have the biggest conflict of interest you could imagine. They are not impartial. And so, what do we mean when we talk about intelligence? What do we mean when we talk about consciousness? I think people would generally agree that, a baby is conscious, but I don't think we would say that a baby is incredibly intelligent, not in the way that people talk about how these large language models work. So that's not the same thing. Now, for consciousness in particular, we don't even know what consciousness is. There is one theory, a pretty prominent one, but one that has its critics. It's called integrated information theory. In that theory, consciousness doesn't have to do with our brains per se, but just has to do with how information goes through a network. Is the information going into separate compartments where it's being processed in particular ways, but then is it also being integrated to create a global, coherent picture? Scientists argue that that's what happens in our brains. What's interesting is that they have looked at the structure of large language models and these other artificial intelligence systems and the way that information flows through that. And they're like, this has the wrong structure. This is not integrated information. So if they're right, then you don't have to worry about these AIs becoming conscious. They never will.
Mhm.
They don't have the structure for it. They are processing information. And in some ways, they may seem very intelligent to us if they're able to tell you what the capital of Iceland is. That may be your definition of intelligence, but it's not doing it consciously.
Yeah. Yeah, that's pretty fair. By very technical definitions, it's very difficult to compute machine intelligence to the same level of consciousness and probably emotional depth that humans have. I find it interesting when making these parallels and thinking about how we define consciousness basically and what systems do they best operate in. Obviously for now it's humans, right? But I'm just, 50, 100 years from now, who knows? I just some things that I've been thinking about recently. But yeah, I wanted to shift more towards more about heredity. You
Yep.
talk a lot about heredity, not just as a scientific idea, but as a deeply rooted cultural one. And she has her mother's laugh. You write about how people have always used heredity to tell stories about themselves. But you also show how these stories can sometimes go wrong, how they've been twisted into these really harmful narratives like eugenics and used to justify inequality. And so now we have things like ancestry tests, embryo screening, and even the way that people are talking about designer babies. There's this idea that if we have enough genetic information, we can make better choices or even build better versions of ourselves. I wanted to ask you, do you think that we're starting to use genetics to chase this illusion of control? What are your thoughts about the way that we're using genetic information right now? Do you think that we should be more careful about it? Do you think that it's overall a net positive?
I think that there's been a lot of exciting advances in using DNA, using information from genomes to understand medical issues that people face. So, there's a lot of our risk of certain kinds of diseases can be traced down to the genetic variants that we inherit.
Hmm.
And because it's getting so cheap to sequence DNA, I mean,
Yeah,
you can get your genome sequenced for a couple $100 now. You have to remember
crazy.
the first genome project cost about $3 billion to sequence one human genome. We're in this incredible time where the cost of sequencing your whole genome is on par with typical blood tests and things like that. How can doctors and all of us use the information in that genome to improve our health? If you have your whole genome sequenced, you might actually be able to discover, if you happen to have like one mutation that causes one, on its own causes a serious genetic disorder. That can be life
Yeah.
changing. Scientists are continuing to find new connections between mutations and new and conditions that they didn't even appreciate before. So that's really important. And on top of that, for common disorders like heart disease, there's not just one genetic variant that might raise your risk. There are thousands, maybe millions. Your heart uses lots of different genes to be a heart, and there are lots of other ways in which your genes influence your heart's health. So now there are scientists who are saying like, oh, we can come up with a score for your risk, a polygenic
Mhm.
score, just by looking at all these things, and that could be really important too. So, I think there's a huge opportunity for bringing genomes into medicine, starting from, as soon as a baby's born. I think it should just be like, just get the genome sequenced, and that's part of the medical record going forward. What really gets people riled up is when you start to go before that. So, for example, there are companies now that claim
Yeah.
that they can do one of these polygenic risk scores for in vitro fertilization. You can choose among a number of embryos for the best one. Now, what does that mean? You can certainly, if you yourself have Huntington's disease, which is caused by one well-known mutation in one well-known gene, it's very straightforward to screen embryos and say like, okay, we're going to only use the embryos that don't have this mutation because that will guarantee you get Huntington's disease.
Yeah.
So that's like the simplest case.
Yeah.
Um, but could you do a polygenic score on an embryo to lower the risk of, say, heart disease? It's that's arguable. I mean, then you're
Hmm.
getting, it's not impossible, but these companies are really promising a lot when talking about what they can do. Then you can get even further afield and start to talk about, can you try to sort of pick out how your child will behave, or their quote unquote intelligence, by looking at a particular polygenic score. And there, yes, there are genes that influence intelligence scores, but each of those genes has a tiny influence. A lot depends on the environment in which those kids are growing up. So
Yeah.
we you can go beyond that into discussions about gene editing with CRISPR. Fortunately, that doesn't seem to be something that anyone's actually doing at the moment, but I think a lot of those same issues apply. I think people will eagerly give their children, like, all the very best advantages in life if they have the money to do it. But I think it's really questionable what exactly they're getting for their money.
I've seen companies out there that are selling genetic scores for leadership potential or creativity risk. And the science is not there, but it's being marketed like it is. So
Yeah.
a lot of people are trying to capitalize on
Mm.
this genetic revolution. I kind of wanted to talk about another concept that you wrangle quite a bit, which is evolution. It's one of the most fundamental ideas in biology and probably still one of the most misunderstood. You've written that evolution doesn't move towards perfection, but just kind of muddles through. It's more like a constant tinkering process without any inherent goal or endpoint. We've kind of built these entire moral systems around the notion of progress and believe that evolution is supposed to get us to the very best point. Do you think we tend to overly anthropomorphize kind of evolution as a whole? Like, do you think we try to give it intents or directions? And where do you think that stems from?
I think that we tend to see evolution as having some sort of agency.
Hmm.
Evolution wants to do this or wants to do that, or evolution made this. I think that's kind of how our brains work. Like if we see something and there's some kind of interconnected complexity to it, we can assume that something made it or someone made it.
Yeah.
That was the view Darwin was contending with when he was developing his theory of evolution. There were arguments about creation based on design, that the body looked designed and therefore there must be a designer. In terms of a scientific explanation for biological adaptations, you just need natural processes. In other words, there are variations from individual to individual, and some of those variations can be inherited, and some of those variations may help an individual have more offspring. Darwin proposed you let that play out, and you end up with the diversity and adaptation that we see all around us. So, but it's still, there, even now, like when you can, there's just a vast amount of evidence in favor of evolution, and we see it in all these genomes of different species that scientists can study. Just the evidence is just overwhelming, but it's still easy to slip into that kind of anthropomorphic language.
Yeah.
I think it's hard for our brains to sort of reckon with this different way that you can get to adaptations.
How do we convince more people to believe in evolution? I saw this statistic the other day that 40% of Americans reject the concept. You're a science communicator, so you probably think about this very often. And I don't know if you've ever talked to people who reject it and whether you've ever thought about how to convince more people to come on this side of things.
Well, I mean, my job is not trying to
Yeah.
persuade individuals, assume that that is what journalists and authors do. I'm trying to write about scientific research as accurately and truthfully as I can. I've received messages from people who said, "Oh, I was a creationist in high school, and then I read one of your books, and it changed the way I thought about things." That's great. I'm glad that experience was able to open somebody up to this amazing, exciting world of evolutionary biology. I have noticed that 40% number might have been that high in the past, but it's been going down in recent years. I have no idea why. It's a question you can apply to all sorts of other things. There are a certain number of people who genuinely, sincerely believe the earth is flat. And you
Hmm.
can find lots of them on YouTube. Why do they believe that? I think that a bunch of psychologists spend their whole careers trying to understand how people believe what they believe, including when it's something that goes totally against the scientific evidence. And I don't, a lot of times as I read that literature, it has to do with these people come to connect these beliefs with their own sense of identity, how they identify themselves culturally, who the other people with whom they identify themselves. I don't know if an article in a newspaper or a book you pick up at a bookstore is going to tackle that. I'm not a biology teacher and I'm not a psychologist.
Yeah.
It's a bit separate from what I do.
I think people tend to misconstrue science communication with this, concept of persuasion. But yeah, totally understandable that if people who need to be persuaded are probably not the ones that are going out to read this literature or read the material. And there's probably some deeper rooted psychological analyses that need to be done to convince people otherwise.
I would say that, people who are trying to understand these phenomena should not get too complacent in their own assumptions about how these things work. So there's a psychologist named Dan Kahan who's done some interesting research looking at people's beliefs about science and comparing that to their overall understanding of science. So you understand how the scientific process works and so on. And you can score people from low to high on this sort of science index, or, sort of general science intelligence, Dan Kahn calls it. There are a lot of people with very high general science intelligence who do not accept evolution or reject climate change, even though that the scientific evidence overwhelmingly shows that humans are changing the climate. That tracks with how religious people are or how they describe themselves politically. You can have someone who has very high science intelligence, but who also happens to be very conservative and will reject climate change. And so you have to push yourself beyond your own assumptions about how these things work to grapple with them.
Yeah. Interesting. I didn't know that, actually. I guess I just assumed that those who are at the most extreme of the scale, or maybe are just not made aware of everything that's out there, basically, or maybe don't have access to that information.
That is not the case.
Yeah, I haven't really thought about that. It just makes me think about, from then on, what is the best way to persuade them? But this is not a problem for me to try and tackle.
Well,
I definitely.
it is a serious issue. It's a serious issue whenever parents bring their kids to the doctor.
Mhm.
That doctor wants to give that child the best medical care possible. And that doctor has to work with the parents. And those parents may have ideas about how medicine works that are just not true. They may say, like, oh,
Yeah.
I don't want to vaccinate my child because that vaccine
Yeah.
is dangerous and the disease is not. I'm just saying, I, as a journalist, my job is not persuasion. That may happen as sort of a side effect, but I'm doing journalism, writing books, recounting history. That's my job. But a doctor is much more in that, has to grapple with those issues that you're talking about just to treat their patients.
Yeah.
Easy. It's not easy. Sometimes doctors give up. Sometimes doctors say, I'm just not, if they decide
Not today.
they don't want to vaccinate their kid, I'm not going to fight them over it because I only have this healthcare chain only gives me 10 minutes with
Yeah.
this patient anyway. So that maybe I can do more good talking about something else.
Yeah, I mean, it's a great point. Shadowed a lot of clinicians in college, and there have been so many times when you ask the routine questions, have you gotten XYZ vaccine? And you do come across patients who said, no, that's not for me. Or I'm remembering one instance, it was a 40-minute back and forth between this doctor had a lot of time, doctor and the patient trying to really come to some agreement. At the end, the doctor was just tired. They tried their best. But these
Right.
things never end up working out. And it's always there of the obligatory, like, would you like me to share with you the science behind why this works? Oftentimes the patients say, yeah, I know the science. I've read up. I don't know how much of it they actually know, but they say they do. That's why I've been thinking about that question recently. How can we persuade more patients and the general public to understand what's backed by the science? I know we're running up close to time here, so I'll just conclude with a final question. We've talked about a lot of things and ended this conversation with what it means to be a science writer and communicator and the misconceptions that may come with that. Being a science writer is almost like a translation, not just from technical language to everyday words, but from one worldview to another. That feels really relevant now when science is often entangled with politics and misinformation, different incentive structures, public distrust. So maybe the last question I'll end off with you is what do you think is the most important quality for a science writer today?
The most important quality, I guess, in this moment, being able to see how a particular piece of scientific research fits into a much bigger picture. That picture might be what's happening to the planet as we continue to push the climate. Each climate scientist may only be looking at a tiny piece of the puzzle.
Mm,
How is a particular line of research helping society? Is it under attack? Entire lines of research that government scientists have been doing about human health are being eliminated right now. You can't just look at a piece of science in isolation as if nothing else is happening.